Assalamualaikum and good day. So today we're going to discuss the last subtopic for chapter 2, which is called as the Euler equation. Okay, before I start with the Euler equation, so let's first look at the difference. So what is the difference between Euler equation and the one that we have seen before? Alright, so the equation that we have seen before is actually known as linear second order equation with constant coefficient. So they are actually an equation in the form of a d square y over dx square plus b dy over dx plus cy, and that is going to equal some function f of x. So it's called as linear second order with constant coefficient because here the coefficient of the second derivative is given by a is constant value, by the first derivative is b, also constant value, and the coefficient of y is also a constant value c. So that's why it's called as linear second order with constant coefficient. And there are two types of equation that we have discussed so under this type of equation. So the first case is when f of x is equal 0, for which this is known as homogeneous equation. And the other type is when f of x is not equal 0, and that is known as the non-homogeneous equation that we solve by using the UC or VOP method. Right, so today we're going to discuss another type of equation which is known as Euler equation. So Euler equation is basically a linear second order equation, but now it has a variable coefficient instead of a constant coefficient. So let's have a look at the form, how the general form looks like. So it's going to be in the form of ax square d square y over dx square plus bx dy over dx and plus cy, so that is going to equal some function f of x. So if you notice, there is just a slight difference between Euler equation and the equation with constant coefficient, but however, because of the slight difference, the way to solve is going to be different as well. So the difference is that for the case of second derivative, now we have a coefficient of ax squared, so that is a variable coefficient because it involves x squared, and the first derivative coefficient is given by bx, and only for y it's a constant coefficient which is going to be c, right? So this is the Euler equation form. Okay, so what we have to do is when we wanted to solve for Euler equation, so there is no specific way to solve Euler equation, but what you have to do is you're going to have to make it into an equation with constant coefficient. So what we're going to do is you are going to convert the form from having a variable coefficient. You're going to convert that to a new equation for which it now has a constant coefficient. Then only we can use the previous methods that we have discussed before. So how do we do the conversion? How do we convert a variable coefficient to a constant coefficient equation? So for the case of Euler equation, there are three substitutions that we're going to have to apply. So let me write down the substitution right here. There's going to be three of them. So the substitutions are, so the first substitution is when you come across x squared d square y over dx square in equation, so that will be replaced by d square y over dt square minus dy over dt. If you notice, what happened is that, so we change the independent variable, so from an independent variable of x, it now has an independent variable of t. The second substitution is that when you come across x dy over dx in the equation, so that will be replaced by dy over dt. And the third substitution is that, so x is going to be replaced by exponential of t. Okay, so that is going to be the substitution that we're going to use. So we get rid of all the x in the equation, in the Euler equation, and we replace that by a new independent variable t. So now let's substitute this. So what happened is that I'm going to substitute this into the Euler equation and show you how we use the substitution in order to convert that to a constant coefficient. So let's see which part that we're going to substitute. First, we're going to substitute this part right here, which is x squared d square y over dx square. And then we're going to use the second substitution to substitute x dy over dx. And then we're also going to substitute the right hand side of the equation, for which x is now going to be replaced by exponential of t. So let's do the substitution down here. Okay, so now I'm going to start substituting. So I just copy down the a, so there goes my a. So I come across x d square y over dx square. So that is now going to be replaced by the first substitution, d square y over dt square minus dy over dt, alright? And then I'm come across plus b, and here goes my x dy over dx, so that will be replaced by dy over dt plus cy, and on the right hand side I'm going to have f of exponential of t, because x is now going to be replaced by exponential of t. Okay, so now let's simplify this equation, because what happened is that I noticed that there are two terms right here which is in the terms of dy over dt. So let's put them together. We can factorize them. So I'm going to end up with an equation of a d square y over dt square plus b minus a, so dy over dt plus cy, and that is going to equal some function f of exponential of t. So if you notice right here, so my equation has no longer a variable coefficient, but it now has a constant coefficient of a, b minus a, and also c. So that is how I convert it to a variable coefficient equation to a constant coefficient equation. So now that we have converted that to a constant coefficient equation, then only we can use the methods that we have discussed previously at the beginning and in the middle of chapter 2. Okay, let's see now how do we solve this type of equation. So let me write over here how to solve. Okay, so step number 1 is, what you're going to do is, from the Euler equation, so you are going to identify the values of a, b, and c. Identify the values of a, b, and c. So where do we get the value of a, b, and c? So it's going to be from here. So a is going to be the number that goes right in front of the x square, b is going to be the number that goes right in front of x, and c is going to be the coefficient of y. And after you have identified the value of a, b, and c, so the next step you do is you substitute into the equation that we have derived above. Okay, let me put over here and on this right over here and substitute into. So it's the equation that we have derived just now. So that is actually a formula. So we're going to substitute into the equation of a d square y over dt square. So basically it's this equation. Okay, plus b minus a dy over dt plus cy, and that is going to equal some function f of exponential t. And don't worry, so you actually don't have to memorize this formula right here. So this formula is actually provided in the appendix section for the final exam. So you don't have to actually memorize that. All you have to do is you have to know how to identify the value of a, b, and c, and just plug into the formula. And the major mistake that I always noticed when students copy down the formula is that, so instead of like having a variable in terms of t, they put it in terms of x. That's wrong. Remember, copy it every single term as what is provided in the appendix. Just change the value of a, b, and c. That's it. Okay, so now that, so this has become an equation with constant coefficient. So then only step number 2 is we're going to start solving the equation. So now I'm going to solve the equation. Right, so our equation is basically in this form right here. So we have a y double prime plus by, sorry, it's not plus b, it's plus b minus a y prime plus cy, and that is going to equal f of exponential of t. Okay, so you have to remember, like, remember we have two types of equation that we discussed before, homogeneous and non-homogeneous. So that is what we're going to do. So if, for example, if the right hand side is equal 0, f of exponential t is equal 0, so that is called as a homogeneous equation. So basically the solution is simply going to equal yc. You just stop under yc, that's it. But if the right hand side, which is now f of exponential t, is not equal 0, so that is a non-homogeneous equation. And as we have discussed in chapter 2, so there are two ways of solving non-homogeneous equation. So the first is by using the UC method. So the second is by using the VOP method. So if you solve this by using the UC method, the solution y is going to equal yc plus yp. So you have to find both of the component, yc and yp. And if you were solving by using the VOP method, the solution is y is going to equal uy1 plus v y2. So that is going to be the solution, right? So you just apply back what we have discussed before. Okay, and of course, and after you have solved, our problem now is that, so the solution will be in terms of y and also t. But then again, our original equation is in terms of y and also x. Remember, I did mention this in class over and over again. I say that the final solution, it should match the given question. If the given question is in terms of y and x, then of course, the final solution should also be in terms of y and x. So therefore, the last step, what we're going to do is we are going to back substitute. So convert back all the t's to be in terms of x. So how are we supposed to achieve this? By using the third substitution. Remember, the third substitution, x is equal exponential of t. So now we are just going to flip it around. So what we're going to use is, so whenever we come across exponential t in the equation, so we are going to replace that by x. And of course, if I were to log both sides of the equation, and if I were to come across t in the function, so that can be replaced by log of x. So by taking log on both sides of the equation, right? So basically, so that is how do we solve the equations. There are 3 steps altogether. Okay, but now before we start with the example, I'm going to give you the idea. If you notice right here, when we do the converting from constant coefficient to variable coefficient, so what happened is that we change the right hand side of the equation. So previously, if you notice at the top, so this is given by fx. So basically what you do is that, so you are converting, so let me put this in another pen, the colored pen, so you can differentiate that. So basically what you did is you convert from f of x, so that is being converted to f of exponential of t. So let me give you an idea first before we start with the example. So how do we convert from f of x to f of exponential of t? This is what we're going to do on the right hand side of the equation. So let's start with some easy functions first. For example, let's say, so if you have a function of f of x is equal x squared, so if I were to change this to f of exponential of t, so the rule is actually very simple. So every single time I come across x in the equation, so that will be converted to exponential of t. And remember, when you have a power, so put a bracket around. So this basically is going to be converted to exponential t to the power of 2. Okay, so which is going to be simplified to exponential of 2t. So that is how you simplify them. Let me show you one more. For example, let's say if you have f of x is equal x plus 2, so plus, so what should I put? So let's say it's going to be a log of x. So let's see what happens. So there's still going to be the same idea. So what happens is that I will be converting this to f of exponential of t. So whenever I come across x in the equation, so that will be replaced by exponential of t. So let me highlight all the places with the x. So now what happened is that my new equation is going to be exponential of t. So there's no t right here, so it retains the value of 2. And on this side, I'm going to have log of exponential of t. And remember, I always mentioned this in class, log and exponential, they are the inverse of each other. So therefore, this is going to end up with being exponential of t plus 2 plus t. So that is going to be our function f of exponential of t. So you have to make sure that you have now converted all the x, and all the x are now in terms of t. So when you are done with that, there's no longer x in your function, then only you're done converting the right hand side of the equation. Then you achieve the conversion. Okay, so now we can start with